So folks, we're back with the answers and let's just have a little look at what we've got. First thing here, just a little reminder that it's for this practical here, the standing wave, one of the required practicals that we've got. And it's where you got that generator that sends a vibration through a string, and that string is either going to vibrate here with half a wavelength or a full wavelength or whatever. You've seen the video. If you can't remember it, then go back and have a look, please. But what we got here is we've got some results, and the results here are from that practical. And I hope it was quite clear that the length of the string was 0.5 meter here. And all you've got to do then is you've just got to work out the wavelength in meters. Now, if we remember here, if you've got complete waves, you don't have to do that extra step of dividing afterwards. It is just how many complete waves there are there, and you're dividing the length of the string by the number of complete waves. That's all you're doing. Now, when you've got that, we've got to write the wave equation. Now, the wave equation is wave speed equals frequency times wavelength. So, we've got wave speed, we've got frequency, and we've got wavelength. So for each of those, we would work it out. And this time I haven't asked you to show all your working. We've done some of these before. So you just need to go into this section here, work it out on your calculator, get your answers in. Now, just make sure you have another look here. I've done these to two decimal places, mainly because it's 3 significant figures and it works out with what we've got here for the accuracy that we've got. We know that 0.5 divided by 4 is 0.125. There's no question about that. We know that, so we've got 3 significant figures there. So the next, we need to calculate the average wave speed, so number 4. Well, we've got these 4 numbers, and there are 4 of them, so we add them together and divide by 4. So we got 6, 5.75, 6.17, 5.88. Divide through by 4 because there's 4 of them, and that will give us 5.95. Now don't forget, that's not the end of it. We've got 5.95 and our missing bit here, unit. Okay, and don't forget the units can be worked out from the table with meters and per second. Hertz, remember, is equivalent to 1/seconds. So you've got meters per second. So do not forget to write in meters per second. Next part, what is the difference between the two? Now it's largest to smallest. Now remember, it's not from the average to the largest or from the average to the smallest. It's the difference between these two. Whenever you're asked for the difference between the two, okay, if you're asked to state the range, it's from something to something. But if you're asked to work out what the numerical range is, then it's the largest, take away the smallest. And that works at 0.42 meters a second. Now here the thing is we've got to consider is what is the amount of error that we have here. Now we've got less than 10% error. 0.42 is less than 10% of 5.75. It's not a massive error, but you've got to take into account here it's quite a considerable amount of error. Like if you said that you were going to run a 100-meter race at 5.75 meters a second, and then somebody else ran it at 0.42 meters a second more, then you'd be a considerable distance behind them by the end of that race. So the question here is it a reasonable error to have, or is it an unreasonable error to have? Well, it's less than 10% error, so we can say that. It's small, but it could still be considered unreliable. Now, usually here what the examiner would ask is, well, give me a way of improving that. Well, the next part here has a way of improving the accuracy. So we've got two microphones together. We're electronically measuring this in a different way. So that gives us a greater accuracy. So what we're going to do here is we're just working out our wave speed. Now we had it before, how to work this out. Now just look here, this is milliseconds. Now what we're going to do with that is we've got to understand what a millisecond is. Well, 1 millisecond is equal to 0.001 seconds. And we're looking at wave speed in meters per second, so let's convert all of these over. Now the way we're going to do that, we've got meters per second, we've got distance in meters, and we've got times now in seconds. So it's just going to be meters per second. And if you remember, per means divide by. So we're going to do meters divided by seconds. And put those through your calculator. And those are your answers. Now, why was it necessary to use a stopwatch? This is about speed. Can we actually use anything that doesn't measure that smaller number? Well, no, this is about magnitude of number. If you've got something that doesn't measure to 0.01 of a millisecond, then that means you're going to have inaccurate results. And it's that. The key here is that you've got to talk about the same accuracy and inaccurate. And then finally, we're calculating a mean. Okay, just a very simple mean again, but this time we've got significant figures to cope with. And again, don't get caught out with the unit. So the first mark here would be for the calculation with the non-rounded number would get you 1 mark. The answer with the rounded number would get you the 2nd mark, and then the units would get you the 3rd mark. So this bit here would be worth 1 and 1 only. This bit here, rounding to the 3 significant figures, would get you a further mark, and then the units would get you the last mark. Thank you very much, guys. Just crack on with everything else you've got to do. Don't forget flashcards and all the rest of it. Keep on going with them, keep on using them, and we'll be back with you soon.